Hi everyone. In this video, I'll be discussing network attached storage versus storage area network. So these are the contents that I'll be discussing in this video. So first let us see what exactly is NAS and SAN. NAS stands for network attached storage and SAN stands for storage area network. They were both developed to solve the problem of making stored data available to many users at once. But they couldn't be more different in how they achieve that goal. NAS, NAS, is a single storage device that serves files over Ethernet and is relatively inexpensive. NAS devices are easier for a home user or small business to set up. A SAN is a tightly coupled network of multiple devices that is more expensive and complex to set up and manage. A SAN is better suited for larger businesses and require administration by IT staff. So let us see the definition of NAS. NAS is a device or devices with a large data storage capacity that provides file-based storage services to other devices on a network. Usually, they also have a client or web portal interface that's easy to navigate, as well as services like hybrid backup sync or Synology's hyper backup to help manage your files. In other words, NAS is with user friendly file sharing. There are few key characteristics of NAS. File level access. So NAS provide file level access ideal for environments where collaborative work and content sharing are paramount. Simplicity. NAS solutions offer straightforward setups and initiative interfaces, making them accessible to users with varying levels of technical expertise. Scalability. While NAS devices can be expanded by adding more drives, there may be limitations in terms of performances and scalability for large scale enterprise use. So, how NAS works? The NAS device itself is a network node. Much like computers and other TCP/IP devices, all of which maintain their own IP address. And the NAS file service uses the Ethernet network to send and receive files. This system employs protocols like network file system and server message block, enabling seamless data exchange between multiple users. So this is a figure that is showing the NAS system and clients connect via your local network. All file service occurs via Ethernet. So let us discuss the benefits and limitations of NAS. So NAS devices are designed to be easy to manage, making them a popular choice for home users, small business, and departments seeking straightforward centralized storage. They offer an easy way to multiple users in multiple locations to access data, which is valuable when users are collaborating on projects or need to share information. For individual home users, if you are currently using external hard drives or direct attached storage, which can be vulnerable to drive failure, upgrading to NAS ensures your data is better protected. For small businesses or departments, installing NAS is typically driven by the desire to share files locally and remotely, have files available 24/7, achieve data redundancy, have the ability to replace and upgrade hard drives in the system, and most importantly, support integrations with cloud storage that provide a location for necessary automatic data backups. So, in summary, so what are the NAS benefits are? It is relatively inexpensive, a self-contained solution, easy administration, remote data availability and 24/7 access, wide array of systems and sizes to choose from, drive failure tolerant storage volumes, automatic backups to other devices, and the cloud. Limitations of NAS. The weakness of NAS primarily revolve around scalability and performance. If more users need access, the server might struggle to keep pace. If you over provisioned your NAS, you may be able to add storage, but sooner or later you will need to upgrade to a more powerful system with a bigger onboard processor, more memory, and faster and larger network connections. Another drawback ties back to Ethernet's inherent nature. Ethernet divides data into packets, forwarding them to their destination. Yet, depending on network traffic or other issues, potential delays or disorder in packet transmission can hinder file availability until all packets arrive and are put back in order. Although minor latency is not usually noticed by users for small files. In data intensive domains like video production, where large files are at play, even milliseconds of latency can disrupt operations, particularly video editing workflows. So now let us see SAN. So what is the definition of SAN? SAN is the storage area network, and it is SANs are engineered for high performance and mission critical applications. They function by connecting multiple storage devices such as disk arrays or tape libraries to a dedicated network that is separate from the main local area network. So this isolation ensures that storage traffic does not interfere with regular network traffic, leading to optimized performance and data availability. Unlike NAS, SAN operates at the block level, allowing servers to access storage blocks directly. This architecture is optimized for data-intensive tasks like database management and virtualization or video editing, where low latency and consistent high-speed access are essential. Key characteristics of SANs. Block level access. So SANs provide direct access to storage blocks, which is advantageous for applications requiring fast, low latency data retrieval. Performance. So SANs are designed to meet the rigorous demands of enterprise level applications, ensuring reliable and high speed data access. Scalability. SANs offer greater scalability by connecting multiple storage devices, making them suitable for business with expanding storage needs. So how does SAN works? SAN is built from a combination of servers and storage over a high-speed low latency interconnect that allows direct fiber channel connections from the client to the storage volume to provide the fastest possible performance. The SAN may also require a separate private Ethernet network between the server and clients to keep the file request traffic out of the FC network for even more performance. By joining together the client's SAN server and the storage of on a FC network, the SAN volumes appear and perform as if it were a directly connected hard drive. Storage traffic over FC avoids the TCP/IP packetization and latency issues, as well as any LAN congestion, ensuring the um, highest access speed available for media and mission critical stored data. So you can see in the figure, that is the SAN management server, storage areas, and clients all connected via fiber channel switch. All file serving occurs over fiber channel. So let us see the benefits of SAN and limitations of SAN. Because it's considerably more complex and expensive than NAS, a SAN is typically used by business versus individual and typically requires administration by an IT staff. Primary strength of a SAN is that it allows simultaneous shared access to shared storage that becomes faster with addition of storage controllers. So SANs are optimized for data intensive applications. For example, hundreds of video editors can simultaneously access tens of GB per second of storage simultaneously without straining the network. So SANs can be easily expanded by adding more storage devices, making them suitable for growing storage needs. So storage resources can be efficiently managed and allocated from a central location. So SANs also typically include redundancy and fault tolerance mechanism to ensure data integrity and availability. So in summary, the benefits of SANs are extremely fast data access with low latency, relieves stress on local area network, can be scaled up to the limits of the interconnect, operating system level access to files, often the only solution for demanding applications requiring concurrent shared access. So limitations of SAN. The challenge of SAN can be summed up in its cost and administration requirements. Having to dedicate and maintain both a separate Ethernet network for metadata file request and implement a FC network can be a considerable investment. But being said, a SAN is often the only way to provide very fast data access for a large number of users that also can scale to supporting hundreds of users at the same time. So let us see the major differences between NAS and SAN. So by considering the use case, so NAS, that is network attached storage, is often used in homes and small to medium sized business. Whereas SAN, that is storage area network, it is often used in professional and enterprise environments. And NAS is less expensive and SAN is more expensive. NAS is easier to manage, whereas SAN requires more IT administration. So NAS data access as it if where network attached drive. Here's SAN servers access data as it where a local hard drive. So speed is dependent on local TCP/IP Ethernet network. So here SAN high speed using fiber channel most commonly available. And network connection, here it is SMB, NFS, SFTP, and WebDAV. Here it is fiber channel, ISCSI, and FCOE. Scalability. So NAS lower end not highly scalable, high end NAS scale to petabytes using clusters or scale out nodes. SAN can add more storage controllers or expanded storage areas, allowing SAN admins to scale performance, storage, or both. So NAS simply connects to your existing Ethernet network. SAN simply connects to your existing Ethernet network. NAS and entry-level systems often have a single point of failure. For example, power supply. Here in the SAN, fault-tolerant network and systems with redundant functionality. So coming to the limitation of NAS, subject to general Ethernet issues, and SAN behavior is more predictable in controllable dedicated environments. Thank you.